Alrighty. I was looking at these over here, the articles over here, um, and I was thinking of looking at how many I've done in videos. Uh, um, and the ones with the cows, I still have more Friedman Freud and the cows, a bunch of that. So anyway, um, this is too long for me to go in depth with this one article, and um, as is the tradition, I want to go through the abstract. Like that's a lot of times the abstract or the introduction. You know, some of them don't really have an abstract, um, and so this one's got quite a good introduction. But there's some good the information, the real information that we're looking at is these right here. Okay, this is kind of the nuts and bolts of what is important about this. My guides have suggested to me that earthquakes don't need an introduction by me. Okay. Earthquakes already got it covered. Okay. So what we're looking is I'm going to scroll down. I'm going to, I think I'm going to do a copy and paste with the introduction on my website and WordPress or somewhere. And you can read it. Like that we've already talked about. I'm not, this isn't about earthquakes per se. So they give an introduction about earthquakes. And so let me just flip through that and I'll get to this part here. Earthquakes are natural phenomena associated with physical mechanisms underlying their origins and actions. It may cause physiochemical changes and even may provoke the creation of related biological phenomena like unusual animal behavior prior to earthquakes. Okay, so this is what we're interested in here. Due to the potential devastating effects of earthquakes, especially the large magnitude ones, people are yearning for means to predict the coming of these natural phenomena in order to create awareness and preparedness of people to the arrival of catastrophic events. Okay, so you can't blame people for wanting to save their own lives and knowing if an earthquake is around the corner. All right, so if there's, in my humble view, if there's any good, use for science and technology, it's for predicting an earthquake so you can, at least have a chance to save yourself, right? I mean, this is really, truly science at its best and its most altruistic, in my humble view, and that's why I'm supporting this, thoroughly supporting the research on this of the prediction of earthquakes based on physiological, factors, physiochemical, and oh, for goodness sakes, looking at the animals, right? Giving of our heart and our time and our love and our care of our four-legged and our animal friends and of what they tell us when there's something going on in the earth that we need to pay attention to. And so the research where we're talking about cows and unusual animal behavior before an earthquake, my God, it's like this is super fucking important stuff. It really truly is. It's well worth the time, whatever effort and time it takes to do this of bringing it to you so you have a sympathy for the natural world. When you talk about the Schumer resonances in Gaia's heartbeat, well, their animal friends are there to help us kind of warn us of stuff that we're too blind or stupid to pay attention to ourselves. I humbly submit to you. Okay, so earthquake prediction. All right, this is the kind of meat and potatoes of it, as it were. As previously stated, that earthquakes are associated. Hold on, hold please. As previously stated, that earthquakes are associated with natural physicochemical changes. Hence, Several of them may be selected to be advanced for prediction purposes. Scientists use data from a network of seismographs connected to each other to gather sophisticated detail measurements of earthquakes around the world. However, these networks help very little with earthquake predictions since they only measure quakes that happen. Scientists can use other methods to get an idea where earthquakes are likely to happen. Nowadays, scientists, oh please, nowadays scientists are using sophisticated devices such as lasers and satellite systems to predict how faults are moving. Though this attempt is not earthquake prediction in the real sense, the information, however, is giving scientists better ideas of where earthquakes are going to occur in the future and can help people prepare for the eventual earthquake. Predicting earthquakes, I missed a letter in there, is not yet possible for scientists to do, but they hope that they will one day find a way. Although scientists cannot predict them now, sometimes scientists know what regions an earthquake might hit. What they do is use the information from previous earthquakes to figure out a region it might hit. Seismologists look out closely on certain selected places where giant earthquakes are expected. In their comprehensive overview on the topic of earthquake prediction, Miller and Lone Tree, and we've heard those names before, they're well known, 2013, discussed the basics of developing methods of earthquake prediction by historically analyzing the events one by one through long-term monitoring of the physico-chemical characteristics of the forces underlying the events aimed at detecting tectonic strain and electromagnetic signals indicative of potential earthquake activity. Starting around year 2000, Ben Lone Tree has been monitoring several parameters of geophysical and solar activity with his custom system and proprietary software. Oh, ay caramba. On numerous occasions, he has been able to detect tension strain originating at various levels within Earth's crust at both local and globally remote locations. He suggests, oh, this is a long one. Oh, good God. All right. No rest for the weary. Uh, he suggests that duplicating and triangulating his monitoring system would immensely improve data collection and evaluation that could lead to highly improved quake prediction and targeting, potentially permitting life-saving counteractive measures. Okay, again, the best use of science that we can, we can hope for. Science and technology. He reports detecting signals as long as 2 days in advance of sorting major seismic activity. Most suggested precursory earthquake anomalies were recorded unintentionally by observing systems established for other purposes. That's an important, I thought that was interesting here. He reports detecting signals as long as 2 days in advance. All right. Most suggested precursory earthquake anomalies were recorded unintentionally by observing systems established for other purposes. Right? This is really interesting to note. Okay. That they're looking for one thing over here, and suddenly, they're looking for, electrics and they, movement here, and they inadvertently predict earthquakes. This is fascinating shit. The following phase of the research is testing a triangulated system. The aim of the approach is to get a low-cost means for significant electromagnetic monitoring and lithosphere, atmosphere, ionospheric coupling. Duplication, distribution, and triangulation of such monitoring systems could significantly improve earthquake monitoring, detecting, and prediction. Triangulation is the process of pinpointing the location of something by taking bearings to it from two remote points. Triangulation from duplicate monitoring stations could help find and map areas at risk in advance. The last phase of the Lone Tree Protocol is a research agenda proposal that outlines wider application and testing of the theory and system, with atmospheric and terrestrial recordings as well as satellite missions. Right? A proposal have next been submitted of setting up a network of 12 ultra-low frequency electromagnetic ULF EM recording sites. One measure is to install them in existing seismic stations. Transportable recording systems could be deployed in rapid response mode in the aftershock region of a major earthquake to record post-seismic EM activity, electromagnetic activity. A reference station should be located in seismically inactive area with relatively low artificial noise. A final comment on Lone Tree Miller's overview is the list of keywords used for discussion and hello, just put it down, there we go. For discussion and analysis such as geophysics, electromagnetic emission, ELE, tectonic strain, earthquakes, geomagnetic anomalies, fault mechanics, short impending prediction, magnetometer, piezoelectrics. Those of you who've been around for a while, you're familiar with that. Piezoelectrics, ULF, magnetoreception, fault lines, seismic waves, P-holes, positive holes, right? Peroxy bonds, ULF, pre-seismic transients, magnetoseismology, magnetometer networks. Oh, good God. I had some keywords for you there. A lot of you, if you've been around for a while, you've got some familiarity with this, right? You're doing good. You're better than the average. With the advent of modern science and technology, the list of premonitory signals has become longer. Among them are sporadic emissions of low to ultra-low frequency electromagnetic radiation from the ground, okay? Occasional local magnetic field anomalies reaching a strength of 0.5% of Earth's main dipole field. Okay. 3, changes in the lower atmosphere that are accompanied by the formation of haze and a reduction of moisture in the air. This is interesting. Large patches, often tens to hundreds of thousands of square kilometers in size, seen in nighttime infrared satellite images where the land surface temperature seems to fluctuate rapidly. Okay. Passing perturbations in the ionosphere at 90 to 120 kilometer altitude that affect the transmission of radio waves. Okay, so these are all technical precursors to you know, that happen with earthquakes, right? This is all some you know, deep dive kind of shit here. Unusual pre-earthquake animal behavior. Okay, so this is where we start getting into the real nuts and bolts of it. Okay, this is why we came here. All right, so noticeable numbers of unusual behavior of animals. Noticeable numbers of unusual behavior of animals have been observed at the Indonesian Safari Park, Cisarua-Bogor. This guy's from Indonesia. He's from a university in Indonesia. Okay, just FYI. 10 to 15 minutes prior to the 7.3 Richter scale earthquake of West Java on September 2nd, 2009, earthworms surfaced in large numbers out of their burial grounds, accompanied by the Yogyakarta earthquake of May 27th, 2006. These stories add to the accumulated global anecdotal reports on the subject, mostly in newspapers, since antiquity. But recent studies in many reputable laboratories indicate that these unusual natural phenomena may have a scientific background and application to use the phenomena for earthquake prediction as warranted. It was with this objective in mind that the AIPI Commission for Basic Science and of Culture have reviewed the issue and reported the results in book form entitled English Transition, Giving Meaning to Unusual Animal Behavior Before Earthquakes. The earliest the earliest reference we have to unusual earthquake behavior prior to a significant earthquake is from Greece in 373 BC. Rats, snakes, and centipedes reportedly left their homes and headed for safety several days before a destructive earthquake. Anecdotal evidence flourishes of animals, fish, birds, reptiles, and insects demonstrating strange behavior anywhere from weeks to seconds prior to an earthquake. Consistent and reliable behavior prior to seismic events and a mechanism explaining how it could work still puzzles us. However, most of the scientists interested in revealing this mystery reside in China or Japan. And not where I am. The cause of unusual animal behavior seconds before humans feel an earthquake can be easily explained. Very few humans notice the smaller P wave that travels the fastest from the earthquake source and arrives before the larger S wave. But many animals with more sharpened senses are able to feel the P wave seconds before the S wave arrives. As for sensing an impending earthquake days or weeks before it occurs, another explanation must be given. Okay. In the U.S., an alleged theory once grew quite popularly that there was a correlation between lost pet advertisements in the San Jose Mercury News and the dates of earthquakes in the San Francisco Bay Area. A thorough statistical analysis of this theory, published in California Geology in 1988, concluded that there was no such correlation. However, another article published in the U.S. on the subject by a respected scientist is summarized along the following lines. The article poses the question, is it reasonable for a seismic escape behavior pattern to evolve, and can such a genetic system be maintained despite selection pressures operating on the timescales of damaging seismic events? Oh. All animals instinctively respond to escape from predators and to preserve their lives. A wide variety of vertebrates already express early warning behaviors that we understand for other types of events, so it's possible that a seismic escape response could have evolved from this already existing genetic prearrangement. An instructive response following a P wave seconds before a larger S wave is not as big a jump as you might say, but what about other precursors that may occur days or weeks before an earthquake that we don't know about yet already? We don't yet know about. If indeed there are precursors to a significant earthquake that we have yet to learn about, such as ground tilting, groundwater changes, electrical or magnetic field variations. Indeed, it's possible that some animals could sense these signals and connect the perception with an impending earthquake. We will mention 4 noteworthy events of global unusual animal behavior phenomena and earthquake related research that have potential to be further explored for practical earthquake prediction and to provide guidelines to community preparedness. The cases we choose are, all right, so we have 1, 2, 3, 4. Ooh, common toads. Buffo. All right. Conclusion. All right. So that's pretty much the whole article. The hell? All right. Hold on. Okay, we're back. All right. We're getting through this. All right. So, gonna read through 4 of these and then the conclusion. Some of it, I don't know, whatever. And then I'm gonna play some music. And I think what I might do is go to the store, just play some. I'll do the real DJ thing, play the music, run to the store, and get some ice cream. I think, and hopefully there's still be some music playing when I get back. I'm 20 minutes into the an hour errand mix, so I think I can get from here to the store and back within 40 minutes. But whatever. Um, it's just we're just winging it. Me and my DJ DJ Verde, um, VJ Verde. Thank you all for being here. I love you. You folks are wonderful. You know, I I appreciate all the support and the love and the PayPal and thank you, Trish. Trish is one of my long time people being here. Kiki was in the little chat yesterday. It's been a while. And some people, David Julie, lurking, uh, just all of y'all. Thank you for being here. This is one of these videos. It's just a fun kind of thing. It's the scientific research that's looking at the Earth as a little bit more than, just whatever. All right. The community observation system during the, let's see if I can do that. The community observation system during the 1975 Haicheng earthquake measuring 7.3 on the Richter scale occurred on February 4th, 1975. And I would have been 7 then, I think. February 4th, 1978 in Haicheng, Liaoning, China. Sorry for butchering that. A city of approximately 1 million residents. Local political leaders ordered evacuations a day before the earthquake took place. The alertness for the coming earthquake stems from the many reports by people in the area of numerous unusual animal behavior, including those of snakes awakened from their winter sleep and exposing themselves to the cold winter environment, laying on the frozen earth and died. Okay, so the snakes came out of slumber and then they wound up freezing to death. This successful evacuation was the only successful evacuation before a devastating earthquake in history, which saved many lives. It should be remembered, however, that the event in question occurred during the Cultural Revolution of China, where the government had powerful control of the country. Right, so they're showing you here where that occurred. Right. Uh, hold on. The Chinese began to study systematically the unusual animal behavior and the Aiching earthquake of February 1975 was predicted successfully as early as in mid-December of 1974. The most unusual animal behavior was that of snakes came out of hibernation and froze on the surface of the earth. Also observed were a group of rats appeared. All these were succeeded by a swarm of earthquakes at the end of December 1974. The following month of January 1975, thousands of reports of unusual animal behavior were received from the general area. In the first 3 days of February, the activity intensified even more, and unusual behavior of the larger animals, such as cows, horses, dogs, and pigs, was reported. On February 4th, 1975, an earthquake of magnitude 7.3 struck the Haicheng County, Liaoning province. The principal focus of research work in China related to animal phenomena has been on the behavior of pigeons. Biological studies on pigeons determined that 100 tiny units exist between the tibia and fibula on a pigeon's leg. These nerve units are connected to the central nervous system and are very sensitive to vibrations. Scientists determined that prior to an earthquake of magnitude 4.0, which occurred in the area of the study, 50 pigeons that had severed connections between the tibia, fibula, and the nerve centers remained calm before the earthquake, while those with normal connections became startled and flew away. Well, that's interesting. Um, in the preface of his book entitled Earthquakes and Animals From Folk Legends to Science, M. I. Ikea outlines his motivations for writing the book, and after hearing the miserable stories of the earthquake victims, and after being involved of 30 years of doing scientific work in a interdisciplinary field between solid state physics, geology, and anthropology, that he is longing for, using his background scientific experiences aiming to reducing earthquake casualties. He admitted that his research may look elementary to specialists, but this is inevitable in an interdisciplinary work where constructive criticism and more refined experiments and theories are most welcome. The book discusses, among others, in separate chapters on legends of earthquakes and animals, followed by elementary descriptions of earthquakes and electromagnetism, EM, experiments on animals showing behavior responses to EM pulses, a rock compression experiment, and animals' responses to EM waves produced by this is BT, produced BT by fracture, plant reactions, EM exposure, unusual atmospheric phenomena such as EQ lights, clouds, fog, rainbows, and unusual formations in the sky, laboratory simulation of reports on malfunctioning domestic electric appliances. Interesting. Finally, discussion on an automatic monitoring system of unusual catfish behavior as an experimental EQ forecasting model. Oh, that's interesting. Automatic monitoring system of unusual unusual catfish behavior as an experimental EQ forecasting model. All right, interesting. Boop. Common toads, buffo, were observed to exhibit a highly unusual behavior prior to a magnitude 6.4 earthquake that hit L'Aquila, Italy, and this was a big one, on April 6, 2009. A few days before the earthquake, the toads suddenly disappeared from their breeding site in a small lake about 75 kilometers from the epicenter and did not return until the aftershock series. Earthquake sensitivity. Earthquake sensitivity in animals has been accredited to their ability to sense such delicate environmental changes in electromagnetism. When pressure builds up before an earthquake, the quartz crystal in Earth's interior is deformed and creates an electric charge. This phenomena, called the piezoelectric effect, can send electric signals to animals who react to a change in the electromagnetism of an area caused by rising stresses on geological faults. Though often subtle and brief, these changes are noticeable in the land surface, in water, in the air, and in the ionosphere. Significant to understanding these diverse pre-earthquake phenomena has been the discovery that when tectonic stresses build up in the Earth's crust, highly mobile electric charge carriers are activated. These charge carriers are defect electrons on the oxygen anion sublattice of silicate minerals known as positive holes, p-holes, chemically equivalent to O negative in a matrix of O2 negative. They are remarkable in as much as they can flow out of the stressed rock volume and spread into the surrounding unstressed rocks. Traveling fast and far, the positive holes cause a range of follow-on reactions when they arrive at the Earth's surface, where they cause air ionization, injecting massive amounts of primarily positive air ions into the lower atmosphere. When they arrive at the rock-water interface, they act as O radicals, or oxygen radicals, oxidizing water to hydrogen peroxide. Interesting. Other reactions at the rock-water interface include the oxidation or partial oxidation of dissolved organic compounds, leading to changes of their fluorescence spectra. Some compounds thus formed may be irritants or toxins to certain species of animals. Common toads, buffo, were observed to exhibit a highly unusual behavior prior to magnitude 6.3 earthquake of L'Aquila, Italy, on April 6, 2009. Potential changes in groundwater chemistry prior to seismic events and their possible effects on animals may have taken place. Okay. Conclusion. Summarizing the facts outlined in the present. Summarizing the facts outlined in the present presentation with the discussions, earthquake prediction is until to date still non-existent in reality. Much research still needs to be done on the subject, including that related to unusual animal behavior prior to earthquakes. Establishing a baseline behavior pattern that can be compared with reactions of various environmental stimuli, and then testing various potential stimuli in the laboratory would be beneficial for developing the desired aspiration. Prior to this, the presence of those stimuli still needs to be researched with regards to precursory phenomena preceding an earthquake, for if these signals aren't present in the environment before an earthquake, a connection is inappropriate, right? So if you're not seeing anything there, you can't say it's, there's some connection. By making people more science literate, and alert towards unusual animal behavior and other natural signals in the environment through enrichment of knowledge, anticipation awareness, and creating social protocols of evacuating people from earthquake hit areas. These social measures have now been significantly improved. Hopefully, a set of understanding will emerge soon in terms of scale, intensity, size of affected area, or finally, in terms of the occurrence or the consequences of the varying degrees of disaster effects by way of natural disaster service response programs carried out by the government and related organizations. The packet of understanding and knowledge may sharpen the anticipatory capacity of of society toward the onset of earthquakes. To improve anticipatory skills, a service program on natural disaster awareness is warranted at the national scene. With special consideration of variety and disaster intensity and the socio-cultural customs and traditions of the local people through intersectional and interdisciplinary ways. Period. Integration and collaboration with other parties, including the local society. All these efforts should likely be organized readily. Yeah, let's organize. Yeah, look at that. Okay. We got um, some references there. All right, this wasn't a long article. I've been through worse. But the next one is the cows. This one, there's a bunch of them. And this is, yeah, this one, I'm not going to read all of this. Uh, yeah, wow. All right. Here. Ah, this is a big article. Yeah, it's probably a good thing I waited till the end to do this. Do the short one first. So oh, good God, yeah, I definitely need some ice cream. I think Ben and Jerry's fudge with brownies. Yeah. So, oh, we're at 2 hours. This is a good mark. I'm gonna do a long mix here. I'm gonna put my shoes on. I think, get ready, start the mix, and then go to the store, limp over there and hopefully I can make it back here in within 45 minutes, I think. 46 minutes. Something like that. All right, so hold on.